Ising model is one of the simplest models that describes the behavior of a ferromagnetic material. Each spin which can either be up or down on arranged in a lattice. Inside the lattice, each spin can interact with its nearest neighbor and an external magnetic field. We can describe all observables of such system in one single sum we call the partition function. In the exponential, we see that the ratio between the energy of each configuration of spins and the temperature. In the energy equation, the sum is performed over all possible configurations. The first term features the sum of all the nearest neighbor interactions of a spin, while the second term is the interaction of the external magnetic field. If the spin is aligned with its neighbors, the energy of the system is reduced. So if the system is surrounded by spins that are pointing in the same direction, the system is more stable. There are different geometries in which these entities may be arranged. In one dimension, it is a simple chain that can have a free or periodic boundary conditions. The solution shows that it has no phase transition. In 2 dimensions, there are multiple ways to construct a lattice. A simple way would be a 2D square lattice. Here, the exact solution of the 2D Ising model was solved by Onsager. With this, imagine the behavior of a system transitioning from 2D to 1D. In this research, we answer the question, how does the effective change in dimensionality brought about by the introduction of regions without spin affect the character and the magnetic properties of the Ising spin system? To answer this question, we introduce another model of phase transition called the percolation model, a tool in the study of critical phenomena. Unlike the Ising model, the system is independent of temperature but is dependent on the concentration and connectedness of occupied states. We found out increasing the regions without spin lowers the resulting magnetization even for temperatures close to zero. This suggests that the existence of critical temperature is increasingly unexpected as the regions without spin expands, thus effectively changing the dimensionality of the finite lattice. We estimate the critical temperature for each lattice with blocked region density ρ. Then we use this to compute for the fractal dimension by utilizing the power law relation with the radius and cluster size.